So looking at number 16 on the slope fields worksheet. The slope field from a certain differential equation is shown on the right. Which of the following could be a specific solution to that differential equation? Okay, actually let me ask you. Do you know what's different about 16 compared to, I think, all the previous ones?
I don't know.
Somebody said it.
No, it doesn't tell us.
It's y equals, not dy dx equals. So be careful about that. This is the kind of the solution to this slope field, but I don't know. So I think the easiest way is probably to just do dy dx on all those and make it like the others. So dy dx equals 2x. dy dx equals e to the x. I mean, hopefully these are all easy ones. Negative e to the negative x. I'm going to switch to y prime because it's shorter. Negative sign. And 1 over x. Okay, we're only looking in the first quadrant. Let's see. I'm looking on here. It looks like it's undefined when x is 0. So just like things I noticed looking at the graph. Undefined at x equals 0.
That makes me think it's either e to the x or ln x or something like that.
So I look at my dy dx's and only one of those is undefined at 0. So that makes me think e. That's only one thing though. Maybe I should try to figure out something else. They're all positive, at least in the first quadrant here. So if x and y are positive, greater than 0, then my slope is positive. Whoops, that should say y prime. So I'm still good for e on that. Sine, well, it only goes to 3, but between 0 and pi, sine of x is negative somewhere in there, especially since there's a negative, so I think that one's out.
Same with e to the negative x?
Well, negative e to the negative x is negative everywhere, so that's definitely out. E to the x is positive everywhere, and 2x is positive everywhere x is positive.
Yeah.
So,
but 2x would be a linear equation, not undefined?
What else? I think at this point maybe just pick a point and see what it looks like. So like 1, 1 would be somewhere in there. So at 1, 1, I mean, I'm pretty sure it's e. I'm just trying to kind of confirm that that's right. At 1, 1, y prime equals approximately, because I'm just picking it off the graph, so I'd say approximately 1.
So that's another e.
E to the 1 is 2.7. I don't think it's that steep. 2, maybe, but I really think it's 1. So like all roads lead to.
All signs point to e.
Point to e. Another way to work these, so it's e. Another way to work these is to graph a few particular solutions and see what they look like. So this is the picture of dy dx, but if I just put a point on there somewhere and kind of sketch out what it, follow the path, and you can pick some different paths if you want. So, like, well, what does that look like? Definitely not y equals x squared. E to the x is more like that, so that's out. E to the negative x goes that way. Cosine just does that. Natural log of x looks like that. So I'm feeling pretty good about natural log of x. So there's sort of two approaches. You can sketch in a curve, and then you have to recognize the curve that you sketched in. So it's like, how well do you know your parent function graphs that you can see a picture and think and recognize it, or at least recognize it amongst 4 or 5 choices. Having said that, number 17 is pretty similar. So why don't you try number 17? So you sketch the picture in, and the only one that's remotely close is D. Logan, you're right. It does look like tangent. So if they had put tangent on here as well as 1/6 x cubed, I don't know if you could tell the difference. Okay. And maybe if they had labeled like where the asymptotes would be for tangent, like if they had labeled that pi over 2, then you would have a better idea. But yeah, so they'll make it. They're not going to make them that close. If you wanted to double check, you could do y prime equals 1/2 x squared, and then check some points. Although x squared is always positive, so that kind of matches up. If x is 0, slope is 0. So a couple different ways it looks like D.
How do you do number 18?
Number 18. On the right is a slope field with which of the following differential equations? Yeah, so I'm not solving that one for sure. Instead, I think I'm gonna plot points or look for key points.
How do you find key?
Well, so I'm looking on the graph. It depends on x and y, but they all depend on x and y, so that doesn't help. Let's see. It looks like the slope is 0 when at y equals x. Anytime y equals x, the slope is 0. That doesn't help at all. They all match that criteria, so that's no good. It looks like it's undefined when x is 0. Y prime, I shouldn't say equals undefined, that's not quite right. Y prime is undefined at x equals 0. So that makes me think A or D. Yeah, because if I divide by 0, that makes it undefined. So I think I'm down to A or D. Y squared minus x squared versus x squared minus y squared. Maybe it's just time to pick a point and see what happens. We already said something about y equals x, so 1, 1 is probably not going to help me any.
2, 3?
I'm going to go 3, 1. 3, 1. I think my slope is positive for sure. And I'd say it looks greater than 1. Right, that looks maybe 2. I don't know. It's positive, maybe greater than 1. Let's see what happens. For answer choice A, dy dx at 3, 1, 9 minus 1 over 3 would be 8/3. Okay, that's reasonable for what that looks like. Answer choice D,
Same thing. Right?
y squared minus x squared, 1 squared minus, yeah, well, you're right, it's the exact same thing except negative.
So it has to be.
So negative 8/3. Well, that's definitely not negative 8/3. So D is out because of that 0.31. And then we already threw out A and B, or B and C, so it's got to be A. So these matching ones are process of elimination and using sort of everything at your disposal. Check a point, look at where things are undefined or 0, where is it positive or negative. And so some people start to like these once they get the hang of it, because they're not, like once you get the tools down, they're not really that hard. But until you get it down, it does feel a little bit weird.
Why was the answer generated?
Because I saw that when x equals 0, the slope was undefined. Like it doesn't show that exactly, but like it's really close to it. It's undefined. So I think when x is, when x is 0. Whoops, that would be this statement, not that statement. When x is 0, I'm undefined. So if there's a x in the bottom, that's what made me think it's either A or D, because 0 in the bottom would make it undefined. If y is 0, maybe take it the other way. If y equals 0, then b should be undefined. At y equals 0, but at y equals 0, none of those are all, they have slopes there. So b is out. Look at 19.
Yeah.
See if you can do 19. So it gives you an initial condition. So put that point on the graph and then see if you can figure out what's going on. Put that point on the graph. So sketch in the picture and then answer the question. Yeah, 20 and 21 are kind of the same type question. 22 is more sketch the point they give you and then answer the question. Oh, but be careful, it does say which one must be false. And since you'll be sketching in a bunch of things, I would suggest
Are you going to start recording again?
color coding.
I don't think you recorded the solution of the last question.
I did a hit record. So for 22, I think I would color code your sketches. That way you can see if the statement is true or not. Skip to 22, try 22, and then we'll be done. At least I'll be done. So start by sketching in the pictures. Color coding them is unnecessary, but may be helpful. And then the graph of the solution through 0, 0, so that's my green graph, is concave up between -1 and 1. No, because it looks like from 0 to 1, I'm pretty sure that's concave down. So C is not true. The others, all the concavity stuff, made sense. Those were true statements. So again, most people like slope fields because there's not, I mean, you can make them be some integrating, but for just slope field problems, it's just sketching pictures, thinking about things, and so it's brain work, not paperwork. If that makes sense. Concept questions, not mechanical find a certain derivative question. Alright, so we've done a big chunk of them. Finish them at your leisure, and I'll see you